Hey guys, Mr. Backward here. In this video, we're going to look at a couple of application problems that involve writing equations in quadratic form. So in this example, we've got a riverboat taking tourists up and down the river. It averages 12 miles per hour in still water. It takes the boat 1 hour and 4 minutes to go 6 miles upstream and then return. We want to find the speed of the current. So hopefully we're familiar with the modeling equation distance equals rate times time. We're actually going to solve this to get t alone, so we would have to divide that r over to the other side. So we're going to use time equals distance divided by rate. Now let's first talk about our boat going upstream. As far as the distance goes, it's a distance of 6 miles. Now the average speed is 12 miles per hour in still water, but as we're going upstream, the current of the river is going to slow our boat down. So it's going to be 12 minus however fast the current of the river is. Now if we talk about going downstream, similarly it's a 6-mile trip, but this time since we're going downstream, that means the current is going to be pushing us along faster. So we're going to take that average speed of 12 miles per hour and we're going to add that current to this. Now we're building an equation in here dealing with the time. So if we add these two together, this is going to be one round trip, one time going upstream and then coming back down. And we were told that it takes our boat 1 hour and 4 minutes to make this trip. Now we're actually going to play around with that just a little bit. So 1 hour and 4 minutes, well we know that there's 60 minutes in an hour. So we can write this as 1 hour and 4 out of 60. But this 4 out of 60 is reducible. So this is going to be 1 and 1/15th, but then I'm going to write this as an improper fraction, so this is going to be 16 over 15. Now this is the equation that we're going to go through and solve to try to figure out our rate. So the first thing we want to do is a little bit of multiplying to help us get rid of all of those fractions. So we're going to multiply by a copy of all of those denominators. So we're going to multiply by the 15, by the 12 minus x, and by the 12 plus x. Now technically this stuff is all over 1, and when we're multiplying fractions together, we multiply the tops, and then we multiply the bottoms. So if I take all of this stuff times this first fraction, then on top, we're going to have the 15, we're going to have the 12 minus x, we're going to have the 12 plus x, and we're going to have the 6, and this is all going to be over 12 minus x. In the middle fraction on top, we're going to have the 15, the 12 minus x, the 12 plus x, and the 6. And this is all going to be over 12 plus x. And then on the right-hand side, we're going to have the 15 on top. We're going to have the 12 minus x on top, the 12 plus x, and then we're going to have that 16. And this is all going to be over 15. Now I'm writing this out in the long form so that we can see the canceling happening. So here in this first fraction, we've got the 12 minus x on top and on bottom. In the middle fraction, we've got the 12 plus x on top and on bottom. And in my last fraction, we've got the 15 on top and on bottom. Now in this first fraction, if we take that 6 times the 15, we're going to get 90 times that 12 plus x. Plus, same thing in the middle here, 15 times 6 is 90, but now we're multiplying that by the 12 minus x. And on the right-hand side, we've got the 16, the 12 minus x, and the 12 plus x. So on the left-hand side, if we start doing some distributive property, 90 times 12 is 1080, and then 90 times x is plus 90x. 90 times this 12 is another 1080, and then 90 times negative x gives me negative 90x. On the right-hand side, I'm going to start with foiling out what's inside of my parentheses. So 12 times 12 is 144. 12 times a positive x is plus 12x. Negative x times 12 is minus 12x. And then negative x times positive x is negative x squared. These 12x's are going to cancel each other out. So then we get 16 times 144 minus x squared, but then I'm going to distribute the 16. So on the right-hand side, we're going to get 2304 minus 16x squared. On the left-hand side, the plus 90x and the minus 90x are going to cancel each other out. And if we add those 1080s together, then we're going to get 2160. Now I'm going to subtract that 2304 over to the left-hand side. and we're going to get negative 144 equals negative 16x squared. Then if I divide that negative 16 over to the left-hand side, we're going to get 9 equals x squared. But then in order to get rid of the squared, we're going to have to square root both sides. Now when we square root things, remember there are technically two answers. So we've got positive and negative 3. Now we have to remember this x is representing the speed of the current for our river. And we can't have a negative speed, so we're going to ignore the negative 3 and just say that the current for the river is 3 miles per hour. Now in this example, we've got a couple of carpet layers, and it takes them 4 hours to complete a room if they're working together. But if they're working alone, one of them could do the job in 1 hour less time than the other. And we want to figure out how long it would take each layer to complete the job alone. So we've got that 4-hour time when they're working together. Now let's talk about the slower worker first. We're going to let our x represent the rate for the slower worker. But then we know that the faster worker can do the job in 1 hour less time. So then the faster worker's rate would be x minus 1. Now we're dealing with this 4-hour time, so here's what we're going to do. We're going to take the 4-hour time and divide it by the rate for the slower worker, and then we're going to take the 4-hour time and divide it by the rate for the faster worker. Now when these two are working together, they can complete one job in that 4-hour time span. Now as we're looking at these fractions, to multiply in order to get rid of the fractions, we're going to multiply by the denominators, so we'll multiply by x and by x minus 1. So on this first fraction, we're going to have the 4, we're going to have the x, and we're going to have the x minus 1, and this is going to be over x. In this second fraction, we're going to have the 4, the x, and the x minus 1, and this is going to be over x minus 1. And then on the right-hand side, we're going to have the 1, the x, and the x minus 1, and technically this would be over 1, but we don't need to put divided by 1 in there. Now in my first fraction, this x on top and on bottom are going to cancel each other out, and I'm going to distribute this 4 in right away, so we get 4x minus 4. In my second fraction, the x minus 1s are going to cancel each other out, so we just get 4x. And on the right hand side, I'm going to distribute this 1x in, so x times x is going to be x squared, and x times negative 1 is minus x. Now on the left hand side, we're going to be able to combine these 4x's to get 8x minus 4 equals x squared minus x. We've got a quadratic in there, an x squared, so we want to get it equal to 0. So I'm going to subtract the 8x over, and I'm going to add the 4 over. So we're going to get 0 equals x squared minus 9x plus 4. Now this equation is not factorable, so we're going to use the quadratic formula to help us solve this one. So remember, the quadratic formula says opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So as far as the opposite of b, the opposite of negative 9 is positive 9 plus or minus the square root of negative 9 squared minus 4 times 1 times 4. And this is all over 2 times a, so 2 times 1 is 2. Now if we work underneath the radical first, we're going to get 9 plus or minus the square root. Well, negative 9 squared is 81. 4 times 4 is 16, so we have 81 minus 16 underneath that radical, which ends up being 65. So we've got 9 plus or minus the square root of 65 all over 2. Now if we split these up, if we go 9 plus the square root of 65 divided by 2 and 9 minus the square root of 65 divided by 2, when we do the addition, 9 plus the square root of 65 divided by 2, we're going to get an answer of about 8.5. And if we do subtraction instead, we get an answer of about 0.5. Now we have to remember that these were working rates for these people, so we actually want to consider which of these answers is going to be correct. And I want to focus on the 0.5 right now. One of our workers had a rate of x minus 1. So if we tried to plug in the 0.5 there, 0.5 minus 1 would be negative 0.5, and we can't have a negative time. So we're going to ignore the 0.5 answer and just work with the 8.5. So one of our workers had a rate of just x, so his rate is going to be 8.5 hours by himself. But the other worker was x minus 1, so if I take 8.5 and subtract 1, then the other worker could get this job done in 7.5 hours. That's going to be it for this video. Thanks for watching.